Okay, so today what we're going to talk about is complex numbers, and our learning target today is I can perform operations with complex numbers. So there's a couple little shortcuts with this. I'm going to show you all the calculator, or excuse me, all the calculations, and then you can actually do a lot of this with a calculator, an TI-83. So first, let's talk about what a complex number is. A complex number can be written in the form a plus bi. So what is a plus bi? The a, this is the real part, okay, and the b is what's called the imaginary part. And you've dealt with imaginary numbers before, but the imaginary part, so the bi is the imaginary part, so a plus bi, that's all the numbers that you know. Probably the most common thing you know about imaginary numbers is you can write it as like 3 plus 4i. So 3 plus 4i is an example of an imaginary number. 2i is an example of an imaginary number. Um, Excuse me, 3 plus 4i is a complex number, 2i is a complex number, 8 is a complex number. All right, every number can be written as a complex number, but where you've seen this happen a lot is this guy right here, the square root of -1. You can never ever do that because you can't take that because that's equal to a complex number, I. So what do we know about that? Well, if the square root of -1 is I, then I guess you could argue that I squared is equal to the square root of -1 squared, right? So what's that equal to? Well, that's equal to -1. And then if you say, well, what's I cubed? Well, I cubed is going to be I squared times I. Well, if you do I squared times I, well, I squared we just found is -1, and so then this becomes -I. And then if that's the case, then what's I to the fourth? Well, I to the fourth is I squared times I squared. So what's -1 times -1? That's right, that's 1. If you take I to the fifth, well, I to the fifth would be the same as I to the fourth times I. Well, I to the fourth is 1, so this is just going to be I. And then you do I to the sixth. Well, that's real easy. That's I to the fourth times I squared. Well, I to the fourth is 1, and I squared is -1, so this is -1. And then you take I to the seventh. Well, I to the seventh, well, that's real easy. That's, how about I to the fourth times I cubed? Well, I to the fourth, you told me just a second ago, was 1, and I cubed was -I, so I guess this is going to be -I. And then you have I to the 8. Well, I to the 8 is easy. That's simply I to the fourth squared. So what's that? Well, that's just going to be 1. So there's a bit of a repetition, bit of a you know, bit of re- repeating and things happening over and over again. So why did we talk about that? What do we need that for? Then that what we're going to talk about is basically you can do any type of exponents. You can add, you can subtract, you can multiply, you can divide, all with complex numbers, and we're going to look at that right now. So you can again use, you can punch this in a graphing calculator and it works out pretty easy. But one thing you can do, for example, is if I take like 6i to the 13th and I multiply it by 18i to the third. Well, I'm going to organize this by 6 times 18 times I to the 13th times I to the third, right? What I do there, I just organized. Now, 6 times 18, that's multiplication. What's 6 times 18? That's 108. And this is I to the 16. That's, I performed multiplication and exponent rules too. All right. So Now I got I to the 16. So if I take I to the 16, I can split this up. Oh, I know I to the fourth I talked about was 1. So I'm going to do that's 108. Isn't that I to the fourth? So what does that become? I don't know. Like I guess that's 1. So that's just 108. Pretty simple, right? Okay. So what we're going to do is some operations with complex numbers. So some operations with complex numbers. The very first thing you can do is adding or subtracting. So if you take some things like if we're going to add, um, if we do like 6 minus 4i plus negative 8 plus 6i. Well, that's super simple. You just add the like terms. So 6 and negative 8, what does that make? 6 and negative 8, I think that makes negative 2. Negative 4i and positive 6i, it gives you 10i. So there it is. Boom. What if it's a negative? Well, if you just do something where it's a negative, then just like everything else, you distribute that negative through. So you get 6 minus 4i plus 8 minus 6i. And then 6 plus 8, what's 6 plus 8? What is that, 13? 13 minus 10i. Real simple, real easy to do. Uh, Multiplication is the exact same, right? Foiling is the exact same. The only thing you gotta watch out for is if you have I squared. I squared becomes negative 1, okay? One thing that happens, I guess, what I can show you is in the case of if I have like 6 over 7i. Well, that's division, so you can't really do that. So what you have to do is you got to be kind of mindful here. We're going to actually go ahead and I'm going to times this by I over I. So I get 6i over 7i squared. Well, what's I squared the same as? I squared is the same as negative 1, so this is 6i over negative 7. And that's it. That's how you handle that business. Okay, I'm leading that up to something like if you have, I don't know, where does it get weird? How about if you have 26 plus I over 8i? Well, you can't have I in the denominator, just like a radical. So I'm going to multiply this. So now I get 26i plus I squared over 8i squared. You can't cancel those out, but this I squared is negative 1, so you get negative 1 plus 26i over negative 8, if that makes sense. Right? All right, good. One more thing that I'll show you that you may or may not remember from a previous math course is if you have really goofy things in the denominator, and I mentioned this before, like the conjugate, right? So like if I have like I over 2 minus 6i. You have to get rid of that goofy looking complex number in the basement, so I'm going to multiply by the conjugate. And now the cool thing about the conjugate is the reason why we talked about it in class the other day. This guy's going to walk through. The conjugate should eliminate anything. So if you FOIL this out, this should get you 4. That should get you 4 plus 12i minus 12i minus 36i squared. So the upstairs gives me 2i plus 6i squared. We'll deal with that in a minute. This gives me 4 minus 36i squared. Well, I squared is negative 1, so negative 1 times negative 36 is positive 36, so it gives you 2i minus 6 over 4 plus 36. So what does that give you? 2i minus 6 over 40, right? 2i over 6, 2i minus 6 over 40, and then realistically, I'm going to pull out a negative, rewrite it as this. I'm going to pull out a 2, negative 3 plus I over 40. That cancels. I get negative 3 plus I all over 20. Hopefully that makes sense. There's one more thing I probably want to show you, and that would be if you're dealing with, well, no, you know what? Radicals and all that stuff holds true. So we'll probably look at a couple examples like that, but it's really the same thing that you've dealt with before. So that's kind of giving you a quick review of the imaginary and complex stuff. I look forward to seeing you in class. Good luck, and may the force be with you.